Well, it's done. Thank you. Let me turn my fire off. It's always nice to have a fire you can turn off. Good. No, relative frequency is not the same as cumulative relative frequency, because what is cumulative relative frequency doing as you move down through the chart? Adding, yeah. So cumulative relative frequency is the step-by-step addition of all the relative frequencies, or however way you want to say that, right? Is that all right? You guys all right? Anybody have any other questions from homework stuff? Can you guys log into Canvas? Let me see. And I created a new module. It's pretty much in order. Right after unit 1, it says unit 2. That's crazy. So that's a new one. And there's 2 new little dudes. The first little dude I want to do immediately, and the second little dude is going to require some lecturing from me because we haven't talked about measures of center yet. So I'm going to share my screen. Hopefully most of you guys are able to access this right now. So we are going to be working on this one. Oh yeah. So we're going to make a box plot, all that kind of business. I'm going to try to remind you guys about how to use the calculator to sort things. Hopefully more of us have a calculator by now, or something equivalent. Okay, are you guys doing okay out there? So if you can, access Canvas right now and pull up this one, Percentiles Box Plot Practice, right? Let me ask again before we get into that officially. Does anyone else have any questions before we get back into stuff? Okay, all right. So let me show you. I'm going to stop sharing for a minute. I don't know if you guys. Is anyone not able to access Canvas right now for one reason or another? Let me see. I got chat person. Okay, let me show you. So when you go into Canvas, you'll see this, right? You'll see all this niftiness. Go to modules. Did I point out the calculator workshop video I put up there? Did I point that out before? I can't remember. Even if I did, I'll do it again. There it is. And then you go down, there's quizzes. There's unit 0, there's unit 1, and there's unit 2. There we go. That's the new one. So I like to do, so, you know, down here is where you can turn in homework, but I'm going to like to create unit 1, unit 2, unit 3. So that's where I'm going to throw worksheets and handouts and stuff. Does everybody see that? Is everybody able to find that? Whoever just logged in, go to Canvas, go here, and then click on this bad boy. So I want to start off with reminding you how to get this in the calculator and get it sorted, because that's going to make all of this much easier. Because the very first thing I want you to do is create a frequency distribution or frequency histogram. A little practice on that, because we haven't actually had practice on that yet, so we might as well do that beyond homework. So let me ask this question again. Is anybody relying on my sharing, or are you able to pull this up yourself on Canvas? Anybody not able to pull this up themselves and relying on me sharing this? Anybody? Going once, going twice, sold. Okay, so everybody's got that sheet themselves. So let me pull up, oh, I should have done this earlier. Where are you again? Oh, dadgummit, Jeff. There it is. Sorry, I gotta find my calculator. There he is. Come over here, dude. Oh my God, it takes so long for you to open. Get over here. I don't know if I've used this in this class yet or not. Have I used this? I finally got an app that mimics if you want the same thing, it costs a lot of money. So no. So let me see. Let me get rid of this. This is weird. Let me get rid of this. All right, guys. So where do I go to input data that I want to use for this class?
Stat.
No way. So that's a really good button to get to know. Stat. And where do I go from here?
Edit.
Edit. Kick ass. And let me know right now if there's anything weird here. If you have stuff in your lists, you can go up to the list, hit clear, enter. Just don't hit delete because then your list goes away. You don't want that. Pull this up for myself. No, Jeff. There it is. Get over there. I don't know how I'm going to do this. I need to be able to see everything. I need a third monitor. I need a freaking matrix setup. There it is. Okay. So let's put that data in the calculator. Are you guys still able to see my calculator? Oh, somebody's chatting. I mean, that's another thing I got to open. Okay. So again, if you got stuff, let me put some stuff in here. Can I put stuff in here? Hello? Oh, that's me. Oh, I'm sorry. I'm trying to put 5s in here, so ignore my chat. So if you got stuff in there, just go to list 1. Just highlight list 1. Bam. Hit clear. Enter. Don't hit delete. If you hit delete, the list goes away. You kill it. Poor little list. There's a way to bring it back if you accidentally kill a list. So let me know if that happens. So let's all put into list 1, all of us that are able to. Let's put all this data in. So 73 and then so forth. Nobody said they needed me to share that, so that's why I'm not. Where am I? Have I already missed something? I feel like I've already missed something. No, okay. This is so exciting, Mr. Waller. All right. Nobody's telling me they have any issues. I like it. And see how I ended up on the 21st spot, which is good because there's 20 data points. You always want to make sure that you got all the data points in there. Just take a quick second for that, right? Yeah. If you want to delete one data point, you can go to that position. Why can't I move? There it is. And then you can hit delete, and that takes care of it. You just don't want to delete an entire list. You can overwrite a data point also. So if this was supposed to be 60, I could just put 60 there, but it isn't. So let me go put 70 back there. 70. Bam. Okay. How's everybody doing out there? Everybody ready for the next step? Who remembers what the next step is to sorting this?
You click stat again,
Good. Stat.
and then sort A,
Okay.
and then you put L1.
Good. Tell it which list to do that to. And again, it's very anticlimactic. I love how I have a battery indicator. I wonder if that's my laptop. I wonder if my anyway, sorry. That's who cares, Jeff. So if I go back to stat, edit, now it should all be in order. Everybody with me? So if you don't have a calculator, go ahead and copy these down because now they're in order. That's a nice way to get them in order. That's really all you need the calculator for at first here, is to get these suckers in order.
Can you show that again?
Oh, how to do the sort? I guess, right?
Yes.
You hit stat and then sort. You can either scroll down to it or you just hit the number 2. And then you have to tell it which list. So second one to tell it list 1. So if I had a bunch of lists of data, I can tell it which list to sort. And then you got to go back into your list stat edit, and now your list is in order.
Thanks.
You're welcome. I like the comment, this is great. And it's like, well, this thing costs $100. You know, it better be able to at least put things in order. But I agree. It's kind of cool to see it happen. All right. So hopefully, so here's the next, oh shit. Here's the next group of numbers. If you're copying these down. Okay. And again, I don't know if somebody entered after we got into this, but there's a sheet up on Canvas that we're working on together called Percentiles and Box Plots. It's in the modules under Unit 2. All right. I'm going to stop sharing that so I can share the sheet again. Share the sheet. I'm going to share the sheet. Well, let me get it. Where are you, sheet? Holy sheet. That's not you. Where are you? Maybe that is you. Sorry. I doubt you. Open. Okay, there you are. Okay, so let me share this. I got this kick-ass cool thing. Let me see. I don't know. Have I used this yet with you guys? All right. Oh, you can't even do that, can you, Jeff? No, you can't, Jeff. That's true. Everything's bad. All right. That sucks. I'm not even sure I'll be able to do this. Oh, no, I stopped sharing. Sorry. All right, now how am I going to do that first thing? Let me see if I can share again. Can't see you guys. There you are. Come over here. Oh, man, technology. You got to love it. All right. So I'm telling to use 5 classes. Let me see if I can do something still here. No, I can't. That sucks. Ooh, what are you doing? All right, I don't want to do that. Too bad, Jeff. Too bad. No, that's not what I want. I have to. All right, I'm going to stop playing around. I'm just going to have to type. That sucks. So I want to use 5 classes. So how am I going to figure out the class width?
Right. It would be the range over the total of numbers.
No, not the total of numbers.
Divided by the class.
Yeah, the number of classes. I like it. Divided by the number of classes. So if you look at your, ooh, somebody's chatting. If you look at your list, your sorted list, what's the highest and the lowest data point?
The highest is
99.
99. The lowest
99.
is
47?
47.
Whoa. Oh, is this different? Hold on, guys. Are these different numbers? All right. You're going to have to excuse me. I'm obviously having a technology day. So, excuse me. I think I pulled up an older version of this. I should just stick with what I have on Canvas. Let me see what I have on Canvas. All right. I'm going to have to stop sharing for a minute. It's too much going on my screen here. There we go. All right. Oh, Jeff. Oh, yeah, there you go. This is the test grades one. Now, why am I having so much trouble with this? It sucks. All right, let me download this just because. All right, get in there. Okay, do it. All right, better. Okay. Let me pull this over there. Woohoo! All right. And there it is. Okay, that's better. That's better. I was going to say, I looked up and I saw that it was supposedly heights of fathers. And I'm like, if some father was 47 inches tall, that's a little difficult to believe, but not impossible, I guess. What would that be? That's way too short. All right. Ooh, let me see if I can do this. I totally can. Very nice. Okay, now I can do some stuff. All right. So like we said, the width. Well, it's still just as bad, isn't it? Oh, well, too bad for you. 99 minus 47. There we go, Jeff. If you try, it works better. Divided by 5, right? So the high minus low divided by 5. And what do you guys get when you do that?
10.4.
You get 10.4. And so what am I going to do with 10.4? Am I going to use 10?
Round it up to 11.
Good. Force that bad boy up to 11. So that's my width. My width is 11. So when I set up my classes now, and if you are somebody that uses the inequality method that I showed you, that second method, I'm not so worried about you. You probably can handle setting that up yourself, but your histogram will look a little bit different, right? You're not going to have the 0.5s in your histogram. Where am I going to start for the first class?
47?
46.5.
No.
46.5.
No. 47, yes. Where's the I got to stop doing that. Where's the 46.5 going to show up?
When we graph
On
it.
histogram.
When you graph it on the histogram, 11. Now, where's the next class got to start if this one starts at 47 and they're 11 wide?
58.
58.
And so where's this class end? Oh, who's chatting at me?
57.
7.
11. So remember, if you look this way, it's always one less wide than it should be because the width shows up this way. So this will be 58 to 68. This will be 69 to 79. Is everybody with me? If you add 11 down, right? This will be 80 to 90, and this will be, hello? Yes? Nobody, you don't want to talk to me, whatever, man.
So every time you do it 10 away from each other vertically?
Horizontal, you mean?
Yeah.
Yeah, because the 11's got to show up here. And since if that class starts at 47, the next class has to start at 58. Are you guys with me? Because the width is 11. That's the way it is. But that cannot also be 58. So it's going to be one less. Yeah. And remember the 46.5 to 57.5, that's where you can see the 11 width. I really don't want to spend too much time on this though, because it's just some, if you don't use the inequality method, you've got to make some, compromises with how you do things. So now I can do the frequency for each. So if you still have your data points in the calculator, okay, why? Oh yeah, because of this. Okay, I can't use the mouse and my pen. So much technology. So if you look at your calculator, you can start easily counting how many things are in each class. So how many data points fall between 47 and 57? If you count them up.
3.
3, right? 47, 52, and 57. So that's 3 things. And then you just keep going. So go ahead and finish that out. Okay, I don't want that. Go away. That's what's freaking me out. There it is. Oh, okay. So let me catch up to you here. Whoa. think that's 9. Was it 9?
I believe it's 9.
Thank you. And then there's only 1 in that poor last class, right?
Yeah.
One poor little dude all by himself. Is everybody doing okay out there? Uh-oh, what's up, Alexis?
Sorry to backtrack a lot. When I understand when we're subtracting the 99 and the 47, could you just explain where the 5 comes from?
Oh, up here.
Yes.
It's because of this.
Oh, well, gotcha. Okay. Thank
Now,
you.
on the quiz, I'm not going to even say this, but when would you use like 9 classes? What would have to happen? Does somebody remember? You can use from 5 to 10 classes, but we're almost going to use what? Because our samples are going to be so what? What was that? We're always going to use 5 or 6 basically because our samples are not going to be that crazy big, right? Because I don't want to take, an hour just to input all the data points. That's not the purpose. Okay. Is that okay?
Thank you.
Cool. So now how do I make this into relative frequency?
You divide it by the total
Frequency
number to get
over
percentage.
20.
Yeah, so it'll be 3 out of how many total?
20.
20. But does everybody understand how to make something out of 20 a percentage really fast? How do you make something out of 20 become something out of 100?
Multiply by 5.
Yeah, so all I have to do is multiply each number by 5, and that becomes the percentage. Because it's out of 20, that's why it's so easy. Now, I already forgot what I just said there. And of course, all these percentages, thank God, add up to be.
100.
100.
Does it always have to be exactly 100?
No.
Close to
Hell
it.
no. Close to it, exactly. I'd say within a percent up and down. So if you get 95 or 103, no, something went wrong. Okay. You created people or you killed people. Both of those are kind of a little creepy. All right, so let me see. Now we are ready to create the histogram. Let me close the chat here.
Wasn't there 2 data points between 58 and 68?
No, there were 3, so let's see. And that would be for a couple reasons. Number one, if there was only 2, then I'd have 19 instead of 20 data points. But aren't there 65, 68, 68? Right? 65,
Yeah.
68, 68. Yeah, so there's 3 in there. One thing that some of you guys can relate to is you have got to make sure that the frequency adds up to be the total that there are. So this does add up to 20, check. Okay, I like it. So now when I go to make it my histogram, everything's going to be tilted, sorry. All right, then I can do, this is where I have to do 46.5 and then 57.5, and I can just add 11 because that's my width. Okay, so there's my scale there. Jeff, leave it alone. It's going to be all right. What kind of scale do I want to use here? And I want to make a frequency histogram. I actually did a little more work than I had to. I didn't ask for the relative frequency, but just to get us used to it. What kind of scale do I want to use here if I'm going to make a frequency histogram?
3.
Yeah, because I only need to get up to 9, right? I want to make a frequency histogram, so I want to use these numbers. So maybe I can do, well, let's do 2, 4, 6, 8, 10. Or you could do 369. That's fine. So then I've got, so the first, and then what are my labels here? What goes here?
Frequency?
Good, frequency. And then down here,
Uh,
Test grades.
Test
good.
grades.
Test grades, kick ass. And now this first bar has just got to be up to 3, and so is the second bar, right? So I might as well just do this. Excuse how slanty I am here. God Lord, you think I'm not on the chunk? Why? Anyway, sorry. And then it wants to go up to 4 for the next one. You can't quite get over there, can you, Jeff? And then it wants to go up to 9. Oh my gosh. I think there's some, it's like that. Anyway, sorry. And then I want to go up to 1, little tiny 1. There you go. So thankfully we're number 1. It's not flipping us off. It's saying we're number 1. You're number 1. Good job. And that's done. Yay. Okay. I like it. So anything you need from there, get it down, because I can't move this down until I delete these. I don't think, or can I? I think I can actually. I'm being silly. Let me see. I think I can move this. Yeah, look at that shit. All right, I like it. You're gonna have to be able to do all that on your own on the next quiz. By the way, this next quiz is gonna be, I might call it a double quiz, because you might realize there's a lot more stuff in chapter 2 than chapter 1. So this next quiz is going to be a little bit bigger. You're going to get more time to work on it. What are any questions? Oh, I got a chat. Any questions on this first problem here? Oh, yeah, sure. If you did it the inequality way, let me change my color here. How do I change my color? There we go. Let's do green. Yeah, buddy. No, let's do dark green. Yeah. So this first class, for example, oh man, what happened? There we go. Somebody else is chatting at me. Too many chats. I can't handle it. Can you post this on Canvas? Oh, and somebody else has got another question. Yeah, if you remind me, somebody email me right now and say, hey, post that answer key thing for the percentiles to Canvas. I could do that. Somebody else has asked me something about corrections on a quiz. We'll get to it. Hold on. So the question right now is, if I wanted to do that one, for example, with an inequality, it would look like this. And then the next one will look like this. Do you see how that's so much better? For one thing, my labels would just be 47, 58, 69. Oh, so much cleaner, so much better. And I don't have to worry about going up and down in my half. Where would 58 go? Which class would I put 58? First or second?
First.
second.
Second.
Second one, because the first one's not allowed to equal 58. So these numbers would be exactly the same. If you don't see that, but you do see this, then do it this way. Nothing wrong with this way. You just got to do the little 0.5 thing, which I always thought was annoying, but it's up to you. Is that all right? Whoever asked that? No, you don't have to do any of that. I didn't have to do anything up here, did I? This is blank. This doesn't, you can put classes up here if you want to. I don't care. Doesn't need to say anything. But you can either put them like this or you can put them like this. You don't have to, if you do it this way, I can see that you're doing it that way. So I don't need any more explanation that you're doing it that way. Somebody's asked me about how to do corrections on a quiz. You just do the ones you got wrong. Do the ones you lost points on. Scan those. Resubmit them. I think, didn't I say, was it this class? I've pretty much decided that quiz corrections are due the day of the final, just like homework corrections.
Yes.
Is that all right? All right. Everybody cool? Everybody cool? All right. Moving on. What am I asking for down here? What does that mean?
Find the 17th percentile.
17th percentile. And you, hopefully you've all still got the data in order. It's got to be in order for this to make any sense. So go ahead and try to do that. Do part B and part C. And I'll just sit here. All right, I'm going to start to catch up to you guys. Catch up to you guys. Come back to blue. So, whoa, why do I keep doing that? Okay, first step, we take 0.17 times, was it 20? Right, 20 data points. So what do you guys get? What's 17% of 20?
3.4.
3.4.
What do you do with that?
Round it up to 4.
By the way, before I forget, a couple people are asking me about this. I always forget this. The book does an exceptionally weird thing for percentiles. You do not have to use their formula. You can if you want to, I guess. It's in there, but it's actually kind of wrong. So this is the way to do it. For part E, I'm going to show you how to check this in your calculator, just pushing a couple buttons. And if you did it the book way to find the 5-number summary, you would get wrong answers. So do it this way. So then I go get the answer, right? So there's always 2 steps with percentiles. There's where's the answer, and then go get the answer. So what was the 4th number?
65.
Yes. So P17 is 65.
Yes.
So then P72 is basically the exact same problem, except I just do 72% of 20. Why is this 20?
The number of.
Yes. So don't always do 20, right? I always have somebody just always use the same number. No. It's because there's 20 data points here. If you had a problem with 38 data points, you put 38 there. So what is 0.72 times 20?
14.4.
14.4. I like it. And then, of course, you just
Round it up to 15.
15th. And then the 15th number.
87.
You guys agree? Yes, okay. 87. Now, this kind of question shows up in the homework. Don't say anything out loud. Does anyone know exactly what this answer means? Don't say anything out loud. Just think about it. And it's not good enough to say that means the 17th percentile is 65. No, you just basically read this in English. I want you to interpret what the meaning is behind this. All right, come at me. Who's got that answer?
It means 35% of the rest of the people did better than you.
You're looking at the 65 in the wrong way. Which number represents the percentage? 65 is the score. Which number represents the percentage? Somebody's chatting at me.
17.
Yeah, 17. 17% did what?
Did worse than you?
Yeah,
Yes.
17% did worse.
You're the 65, yes. So 17% scored less than 65. Right? Don't be so down on yourself that you're saying you're the 65. It's not necessarily you that's the 65, just 17% scored less than 65. So percentiles always mean that percentage is below the given value. So they could be good, they could be bad, depends. If you're talking about income, higher is better. If you're talking about amount of money you owe, lower is better, right? Talking about golf scores, lower is better. What's up, Vanessa?
Will it always be below, or will there be times where it's below or equal to? And how do we differentiate between those answers?
So the funny thing about what you're asking is it doesn't get that detailed. All right, so for example, the formula the book uses is way too complex for a small set of data. And it gives exactly the same answers as the method I use for larger sets of data. So percentiles really aren't meant to be like really precise. They just aren't. In fact, can anyone tell me without doing any work, let me see if anybody gets this, without doing any work, what is the 18th percentile for this data?
Maybe 68?
Nope, it's 65.
Oh, sorry, yeah.
65. What's the 19th percentile? 65. Of course, there's a lot of repeats because how can I've only got 20 data points. How can each percentile get its own data point when there's only 20 data points? Does that make any sense? No.
Does
Go ahead.
does the percentage above it matter too, or no? Like in some cases where maybe you're talking about like, I don't know, the prices of things, you could say like 17? You could say like 83% are the number of houses like you can't afford.
Yeah, so in this case, you could say, like, I think the person that was trying to answer the question first was trying to turn it around, which is fine. You could say 83% scored higher than 65. Yep. And notice the question somebody asked earlier about, well, does it equal 65 or not? And it really doesn't matter when your data set gets really big. Right? So if I'm talking about 18,000 data points, and I'm like, oh, I had one too many data points. I take that 1 point out. Does that really change the percentages at all? No. Right? If I'm counting 3 million people and I'm like, you forgot Fred. He gives a shit. Sorry, Fred. You matter, but not really. I mean, it doesn't really change the percentages. I'm not sure if that makes sense for you guys, but that's why percentiles, there's a certain procedure we use. It doesn't have to be as complex as the formula they use in the book because essentially percentiles are to get a feel for stuff. The more precise you are, it doesn't make it better. I don't know how to say that so you don't take it the wrong way. You still have to do all the work. You still have to do all the work correctly. But they are more to get a feel for where things are in the data. Okay. Is everybody cool so far with the stuff, what we done? For the most part? All right, now does anyone remember, I think we did this right at the end. I did this very quickly. Anyone remember what this reference is?
Minimum.
The quartiles.
Yeah, exactly.
Box
And I
plot.
heard somebody start to say it. It's the min or low, right? Min, Q, 1, Q.
Q2.
All right, screw it.
Q3.
I'll do it all myself. That's fine. Oh, somebody's helped me out. And the max. Or I usually say low and high, but somebody already said min, so I'll say max. Cool. So min and max are easy enough. We already know what those are, right? We used it to get the range up here. So it's 47 and 99, right? Weehaw. become a thing. There you go. So I'll do that. Look at all the work I've done. Whew. Now you guys just do these things. What does Q1 mean again?
The 25th percentile.
Good. And of course, Q2 and Q3 are easy enough then to figure out what they mean. But now you got to figure out what they are. Oh, you don't want to go up any further? Fine. Be that way.
I have a question.
Yes.
When you're finding it and you get a whole number, do you use the number after, like when you're trying to average it, do you use the number after the, like say you got the number was 2, do you use 1 and 2 or do you use 2 and 3 to get the average?
Use the number you got in the next one.
Okay.
Yeah. So let's do this first one together. Let's see what we get. So 1/4 of 20 is everybody with me on this first one?
Yes.
25%. Yeah, yeah, 5. So that means what? I'm going to take the
Fifth number
5th and
6 and divide it.
average them. Yes. So then when I do that, what are the 5th and 6th numbers?
68 and 68.
Oh, sweet.
Yeah.
That always kicks ass. Right? So each of these should work that same way. So why did we do different stuff up here for these? Why did I do something different here?
They were decimals.
Yeah. So if it comes out to decimal, you round up and you take that number. If it comes out to a whole number, you average that with the next one. Oh, Vanessa, is that your hand from earlier? Or is that a new question?
Oh yeah, you answered my question. Thank you.
All right, let me see. How do I? All right. So many things happening. Too many things happening. There we go. I have the power. Let me see. Do I have the power? Oh, there we go. There it is. Haha. All right. Uh-oh. Somebody left. So the P50 will be half of 20, which is 10. So I'm going to take the 10th and 11th. And what are the 10th and 11th numbers?
80 and 82.
It should be 73 and 80.
73
Hold
and
on.
80, yeah.
I'm outsourcing it right now. I was about to go look. I do have an eraser. Let me see. You don't want to do anything, eraser? There it is. Get out of there. All right. So what is it now? Do we all agree? 73 and
80.
Yes.
153 total. And then divided by 2 was 71.5.
76.5.
oh, can't be 71.5. Yeah. All right. The other way to do that is there's 7 apart. Cut in half is 3.5, and then you just add 3.5. Bam. So that's P50. And then P75, real quick, I would do 3/4 of 20. And that would be, get in there, 15. So I want to take the 15th and 16th. I gotta get used to this pen. 15th and 16th. And the 15th and 16th numbers.
87 and 88.
87 and 88. That's a nice one. Let me see, let me get back here. There. 87 and 88. So of course that's going to be 87 and a half. Bam. I have left myself no room for my box plot. That sucks. I'm gonna have to put it up here. I'll do it in some different color here. Let's see. Do. O'Reilly. So we'll put the box plot in red, blood red. So the box plot is simply, I want to go from 47 to 99. So maybe I'll go 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. Good job, Jeff. Thanks, Jeff. Oh, crappity dude. Let's do every other one back here. Fine. You can certainly give yourself some more room for this. It's probably a good idea. And then now just put, what do I put above each one of these? Anybody remember?
A line.
A line. I like it. So 47 is about right there. 68 is about right there. What else we got? 76 and a half. Let's be precise. There we go. It's exactly right there. 87 and a half. What happened over here? Oh yeah. 87 and a half is about right there. And then 99 is about right there. Did I go insane? Let me see if I did. You never know. No, Jeff. Well, it should be closer. Screw it. So let's see. Bop. And that looks good. Blop. And that looks good. Blop. Yeah, okay. That looks good. And then these middle three are the box part of the box plot. And then you make your whiskers. There should be a box and whiskers, but oh well. Bam. That's how you make it. So yes, I can, in fact, I can save this. I will do that right now. There we go, okay. And then I can put it up on Canvas if somebody has reminded me. So we got what they want from this mess here. It's not quite as messy if I was still using my mouse to write. So let me stop sharing and I want to show you, everybody's got these obviously. I want to show you the calculator, give you these 5 numbers directly. Stop sharing. So if I go back to my calculator and I've got the data in here already, one of the most useful buttons in our calculator is going to be stat calc 1 var stats. This really means 1 variable statistics. So if I had 2 variable statistics, I would use number 2. It's amazing. But I only have 1 variable that I put in there, test grades. Don't tell me I have 20 variables. I have 20 values, 1 variable, test grades. So if I hit this, number 1, let's see what it tells me. So it wants me to know what list I want to use. Is there a frequency list? Nope. And then I calculate. Now look at all this nifty stuff up here. I don't know if you guys remember, we did talk about what that means. Anybody remember?
Sample mean.
Sample mean. I love it. So if I look down here, does anything look familiar?
Everything we just did.
Everything we just did is right. Kick ass. Now, some people might look at that and say, well, why the hell do we do all that shit then, Mr. Waller? Well, because we got to know what the hell's going on. This is a great way to check your work, but this does not mean you understood it. So unfortunately, there are some teachers that only show this. And some of you guys are like, God, I wish I had taken, who is one of those people? Can I still switch? And I'm like, I'm going to shed some tears and then I'm going to stop crying. but I'd much rather you, well, anyway, it's my job to make sure you understand ideas, not just buttons. Please, dear God. Okay, enough of that. So, are there any questions on that? I think maybe we should take a little break, and then I want to get into some new stuff. What time we got? 2:20. Okay, that's good. Perfect. Is everybody cool with that?
I have a question.
Yes, sorry.
When making the box plot, do you want us to label like the quartile ranges, or is it just fine just having the picture? Like, do you want to put Q1, Q2, or no?
No, no, you don't, because it's understood what each thing represents when you create that.
Okay.
Yeah. By the way, in the book, in the writing, you'll see something called interquartile range, which is really just how long is the box. That's all that is. So you do whatever Q3 is minus whatever Q1 is. So for us, what would have been our interquartile range for what we did? Oh shit, where's what we did? There it is.
52.
What's Q? I'm sorry, do it again. Sorry.
19.5.
Yeah, 19.5. Right, Q1 taken away from Q3. So Q3 minus Q1. That's what's called the interquartile range. And there's actually, this will be the last thing I say before we take our break. There's actually a way to use the interquartile range to see what the outliers are. The interquartile range could be used as kind of a unit of measurement. So if any data point is more than 1.5 interquartile ranges away, then that would be considered an outlier. I'm not going to get that deep into that because there are better ways to determine outliers that we're going to learn very soon, more generally used ways. So let's take a break. Let's take like a 10-minute break. Is that all right?
I have a question on the
Yes.
2.3 homework.
All right, so let me officially, let's all take a break. Let me stop this. There we go. That's better. Thanks, Janik. I love that shit. That's awesome. That's sort of like the equivalent of sending an email or forgetting an attachment. This is equally annoying, forgetting your mic. So we're going to get back into what we started getting into, the measures of center, right? So we talked about mean, which is the math name for average. Come on, E. All right. So does somebody remember oh yeah, that's right. I wanted to do a little bit more with, this is where we saw our first Greek letter. What's the difference between these two? The formulas are the same, but this means what and this means what? What does this mean?
Mu means population mean.
Yeah, population mean. So of course this guy is sample. I like it. Okay. So I want to play around with this summation symbol a little bit because I don't think we did last time. You can correct me if I'm wrong, but if I have a set of data, so for example, this is what I have here. Can somebody tell me what this would be?
The sum of all the x values.
Yep. There we go. Catherine's got it. 30. Now. How would you calculate that? And I will tell you this. You don't square 30. So here's what's going to get us through this semester. We're going to see a lot of formulas that will have this symbol in it, which makes sense. A lot of basic computations deal with adding a bunch of shit up. So you're going to see this symbol a lot because we're going to be adding a lot of shit up. So if you cover it, you see I need a list of those before I can do that? Because this says sum these up. Do I know what these are yet? No. Why was this easy? Because I know what the x's are. There they are. Add them up. Do I have x squares? Shit, no, I better make them. Does everybody get that? If you cover that up, you go, do I have those yet? No, let me make them. Okay. So of course, what do you get?
16, 25, 81, 144.
Yeah, so what's sum of x squared? 276, is that right? Did I do that? I think it's 276, is that right? Or is it 266?
266.
Thank you. All right, so now, guys, think about this. What is this one? Don't say anything out loud. Can everybody see that one? It's a little bit low down there. Poor little dude. Sum of 2x minus 8. Let's see who listened to me. Try to figure out what that is.
Zero.
What's that?
Is it 0?
No. I mean, the first one is 0, right? So what do you have to, again, cover that up. What do I need? I need a bunch of 2x minus 8s. Do I have them yet? No. So let me make them. So what's twice 4 minus 8? That's 0. I agree with you, but that's not everything. What's twice 5 minus 8?
2.
2.
And what's twice 9 minus 8?
10.
And what's twice 12 minus 8?
16.
There you go. And so, of course, you get
28.
28.
28. So the big thing, is everybody with me now? It's sort of like you're making an XY table in a way, and this is telling you what function to use, but you don't have to look at it like that if that brings back bad memories of algebra and all kinds of stuff.
I'm sorry, I have a question.
Sure.
How'd you get 16 to 0, 25 to 2? What are you doing again? I'm sorry.
Oh,
On the
this
chart,
is
yeah.
its own thing. You're cool with all these numbers, right? That's just
Yeah.
squaring them. This is its own thing. How do I create it? I double X, and then I subtract 8. So twice
Gotcha.
4 is 8, minus 8 is 0. Twice 5 is 10, minus 8 is 2.
I have a question.
Thank you.
Wait. All right, you're okay. Okay, now what's the other one? Yes.
Where did the 4 come from for x?
I had to give you these. These are the data
You gave
values.
it to us? Okay.
I have to give you the data. I can't say
So
calculate
in the
something
homework,
with the data. I'm not going to show you the data. Huh?
in the homework, it'll provide that for us?
Yeah, it has to. Yeah.
Okay.
Or it has to give you a way to find it somehow, right?
Got it.
So they have to give you the data. Okay. All right, is everybody with me so far? Okay, so that's just so you know what that symbol means. We're going to see it a lot very soon. So the second thing about measures of center, these are all ways to measure where the center is. So we normally think about this first, averaging a bunch of numbers, but there's a second thing. And let me ask you this. Why wouldn't I tell somebody the average home price in San Diego if they're considering moving here? Why is it not really accurate?
Because there's certain houses in this area that are very expensive that would still get the price.
So I like walking around those neighborhoods and going, there's a house I'll never even be invited into. Looks really nice. And I just keep going. Right? Maybe I'll be invited in. Who knows? But I'm a teacher. I'm never going to own the damn place. That's for sure. Now, that's just one example. So you almost always see in newspapers, I don't know if you guys realize newspapers still exist somehow, or in articles on the internets, you always see them talk about median home price. They don't talk about average home price because there are extreme values that will make the average get biased in that direction. What about if I have a company and I'm the CEO and I've got 3 employees? How does my salary compare to their salary most likely?
Way much bigger.
Yeah, dude, especially me. I'm a jackass. So if I had, let's say, one guy makes 40, another one makes 42,000, somebody else makes 44,000, and then I make 400, let's say 500,000. Yeah, that's me. There you go. I'm just like Jeff Bezos. I'm evil, although I'm going to keep my hair. So would it be, if somebody else wanted to work here, would you tell them the average salary to give them an idea of what they can expect to make? Hell no. But what's the median of this data? How do I find the median? I can't remember. I don't know if I've even talked about this yet, but the median is the number that's in the middle. There's another name for that. We've actually already calculated medians today. What percentile would that represent? The number that's right in the middle?
50th?
50th. It's the 50th percentile. So what number is right in the middle of these?
42.
I don't know if you can really read these.
Oh no.
Between 42 and whatever that other number is. 44.
So what number's right in the middle? 43,000. So the median here would be 43,000. Right? So that is a much better number to give them as an estimate of how much money they can expect to make. Right? Now, if I average them all, it's going to be affected a lot by 500. But see how a median is not affected by outliers. Right? Outliers. Always think about Children of the Corn. If you ever seen that movie. Outlander. All right, I'll stop. Sorry. So that's median. And it's got a symbol that looks a lot like this. But it looks like this guy had a rough night. It's X with a little tilde on top. That's the symbol for median. So what's the median of, let's do another one. What's the median of this data here?
Two? Is it 2?
Definitely not.
6.5.
What do you have to do first?
You ordered
Do you have
them.
to add them? Oh,
You
order
understand?
them.
It's not, if it
Okay.
could be any order you want it to be, then you can tell people anything you want to tell them, which sometimes it feels like is already happening. But
So now-
I have to put this in order.
So
So
would it be
2,
9?
yeah, now it's 9. Good. So 9 would be the median. The median would be 9. Why didn't I have to do the average like I did here?
Because it was a whole number and an
Yeah,
odd
there's an
amount.
odd number, right? So for any odd numbers, there's definitely one in the, oh shit, there's definitely one in the middle. Let me be careful. All right, that would be bad. My dean is saying, we're going to talk to you, Jeff. You just flipped off your whole class. Oh shit. All right, how are we doing out there? So these, again, there are definitely times that this is a better measure of center than this. You guys with me?
Yeah.
This one still wins. This one is still better on the whole, but there are situations where this one's even better. So there's 2 more measures of center. There's one called, in fact, what kind of sucks about, what kind of data can we have? This, so far we've been talking about one kind of data, numbers. What kind of data is that?
Quantitative.
Quantitative.
Quantitative. So what if I have qualitative data? There's
That's,
actually a way. Sorry.
Categorical meaning like names.
Yes, exactly. Categorical. So we do have a measure of center that works with categorical, with qualitative data, and that's called the mode. And the thing to remember with the mode is it's the thing that occurs the most. So it works with numbers, it works with not numbers. So for example, if I look at a classroom and there's 38 people have brown hair, 23 people have blonde hair, 2 are bald, and 1 has green hair, and that's it. What's the modal class? What's the one that occurs the most?
Brown.
Brown. Okay. So that is a way to use measure center for non-numerical data. Okay, I like it. So it's just the class that occurs the most, the thing that occurs the most. Now, obviously, it works with numbers too. What's the mode here? Amazingly enough. What's the mode?
2.
Holy shit.
2.
And then what's the mode here? Let me see. Where, Jeff? Hold on. The mode there is 2. What's the mode in number 3?
2 and 4?
2 and 4.
It's bimodal, right? Don't judge. You can be jealous. It's bimodal because it's got 2 modes, 2 and 4. I like it. And then we can also have trimodal. There can also be no mode. Is there a mode here?
No.
No.
And if it goes above 3, we just go, okay, there's no mode. So mode is a way to measure where's the data clustering. Is there somewhere it seems the data is clustering? And once it's more than 3 places, you go, it's not really clustering anywhere then. So you can have no mode, 1 mode, 2 modes, bimodal, 3 modes, trimodal, and then after that, it's like, holy shit, no mode. Okay, maybe. Okay. I like it. And then the last one, I'm going to erase all this. Let me erase just this part so far. Last way to measure the center is something called the mid-range. And now think about how that sounds. Mid-range. So if I had a group of data, what would your gut tell you how to calculate the mid-range?
So do you set up an inequality?
No.
Is
What's
it the
range? What's the range? The range is its own thing. How do I calculate the range?
Oh my.
2 to
Highest
16.
to lowest?
High minus low. So the range is 2 to 16. It's 14 here, right? What about mid-range? Where should that number be? It should be in the
Middle.
Middle.
middle of the range.
Range.
So what's right in between 2 and 16? How do I calculate that?
7?
Yeah, no, not 7.
16 minus 2 divided by 2?
No minus. How do you calculate the middle of 2 things? You average them.
Yeah.
No, Jeff. That number you said earlier stuck in my brain. 9. How far away from 2 is 9?
7.
7.
How far away is 16 from 9?
7.
So is it 9 in the middle of 2 and 16?
Yes.
Yes, there you go. That's how you always calculate the middle number of 2 numbers is you average the 2 numbers, like we did earlier with percentiles. We were averaging 2 numbers. We were added it up, divided by 2. The reason that sucks is because range is subtraction. I know, I understand. Mid-range is an average, so it's actually high plus low divided by 2, and that sucks so much. A lot of you guys are going to do minus. I understand why, but I'm still going to take points off because of my earlier statement about me being an asshole. Okay. So just don't do that. Do it the right way. All right. Whenever I make that joke, I know there's somebody out there going, you think you're joking. Okay. That's all of the measures of center we'll talk about. Thank the gods, right? That's plenty. That's enough. I want to get, so here. Before I get too far ahead, I think a decent number of you guys are able to access Canvas. I think a decent number actually did that earlier. If you go into Canvas and you look in the same place that we got that earlier sheet, same place we got that percentile sheet, right below that it says measures of center practice. So let me share the screen real quick just to show you. All right, let me do this again. Sorry, let me start over. So if you go to modules, and you go to down here, pass unit 1 into unit 2. There's the one we did earlier. And by the way, here I did put the answer key already. Woohoo! But if I go back here and I do this other one instead, measures of center practice, that's what I want us to work on right now. Let me ask this again. Please just tell me honestly, is anyone not able to access this right now on their own? Just tell me. Anybody not able to access this on their own right now? Okay, cool, sweet. Then I'm gonna go ahead and put you right into groups. I want you all to start working with each other immediately, right? Normally I'll let you, I'm gonna try to put you into groups of 4. You see why? If you're looking at the sheet, do you see what you gotta do? You gotta do it for 4. So if I put you into groups of 4, then you can divvy up the work amongst all of you. See how that works? So I'm gonna stop sharing now. And let's see, how many people do I got? 42, shit. 42 is awesome because it's the answer to life, universe, and everything, but it doesn't work for groups of 4. Damn! Oh well, I'll do it again. Let's see. I guess there's really 41. So how am I gonna do this? Let me see. Let's see what happens if I do this. All right. So one group is gonna have 5 people. So, oh well, that's the best I can do. Everybody understand what's happening now? I want everybody in their groups to work on that sheet. You all said you could access it. Please work together on that. And then call me in if you need some help. So here we go. Bam. And, oh, sorry. Bam. Now go. Go away. Work on that sheet. Let's see who's not here. Is anybody not here? And then there were 2. So Yvonne and Charles, are you guys out there? Hello? She's always recording me. We got about 10 seconds for everybody else. Oh, that's that one person. Oh, geez, whatever. Sorry, somebody's not really here, so that's why they're still there. Okay. All right, everybody should be back. At least your little box with your name in it is back. So obviously what you guys realize about all the groups of data as far as measures of center, they were all exactly
the same. They all equal 13.
So I'm almost certain that some of you guys are like, what the shit? What? We're doing all this work. They're all the same. Oh, well, you didn't know that till you did the work. So the whole point of this, let me share this and let's work on this together. Oh, where are you? Oh, I love it. I love it so much. There you are. Get up there. And then let me share you. Kabam. Let me plug you back in. All right, so help me out. We don't have much time at all. We have very little time left. In fact, do we really even have time left? What time is it? Yeah, technically we got time left.
4 minutes.
Yeah, I know, man. You guys are so spoiled. I normally let you out early. Too bad. Which way do you go? I can't remember. Let's see what happens here. Okay. Oh yeah, so it goes this way. Yeah, I'm wasting time. All right. So I'm gonna have to do this. Oh, sorry. So sorry. Hold on. There it is. Okay. Good Lord and a half. Please let me go back to campus someday. Please share this. Okay. All right. So this 13. All right. Everybody was 13. In fact, even the ranges, I didn't make you calculate the ranges, but what's all the ranges?
13.
Say again, sorry.
14?
14. I like it. So my point is, I can see that the lists of data are different, but the range is the same for all of them. All the measures or center are the same for all of them. So there must be something else that I need to use to differentiate. So what I'm trying to do down here, obviously number 2, I would say, would you say that each group of data is the same? No. Does that agree with what you found in number 1? No. Because number 1 said they're all 13. But we know, we can see that all the lists are not the same. They're not the same list of data. What'd you guys get here? I think this one should be 80101. Is that right?
Yep, that's right.
Yes.
And then I think C was 2222. Is that right?
Yes.
Yes.
And then I forget about the other ones. It's been too long since I did this.
12421.
And then this one was 32. Is that right?
31213.
213. All right. So what I was telling some of the groups is, if I think the mean, if I call that home, if I call the mean home, which group got further away from home? So like frequency, like group A, 8 of them are right next to home, right? It's like you move out of the house, but you move 3 doors down. Like, whoa, not really independent. Oh, well.
Big group D.
And then group D, more of them got further away from home, right? So I would say, which group is obviously more spread out?
Group D.
Yeah, the most spread is D. And the least spread is A. And of course, the 2 in the middle kind of go. So least spread, a little more spread, a little more spread, most spread out. So what we got now is, if I can tell somebody the mean of a set of data, and somehow next time we're going to make this into a mathematical thing. We're going to make a number that measures the spread. So if the spread of this one was 1, then the spread of this one might be 3 or something. It's going to be bigger, right? So whatever this number is, the bigger it is, the more spread out my data is. The smaller it is, the tighter my data is to the mean. The closer all of it is to the mean. Does that make sense? And I think officially I'm out of time now. Yeah, shit. So next time I'm going to give you guys a couple of real life examples of how I want to use spread, and then we'll get into the math behind the spread. And just in case, just so you know, the spread is officially called standard deviation. I'm looking this way because now you're all on this screen. I got 2 screens. It's called standard deviation, if you've ever heard of that. All right, class is officially over. If anybody has any questions, oh shit, what's up? How to find outliers. Oh yeah, okay. Let me see. So I'm gonna, real quick, let me see, how can I do this and be lazy? Screw it, Jeff. It's all right. Don't be lazy. Let me see. Did I start recording? Yes, I did. I'm going to stop recording.